I'm Harshit. I will be explaining about my digital assignment one. So I have chosen a 32-bit microcontroller of NXP LPC1114, which is manufactured by Philips. So coming to the first question is about the block diagram of the microcontroller. So I have drawn these block diagrams and the flowcharts using the draw.io website. So it is freely available to everyone. So it is very user friendly. You can select the components you need to draw the flowchart as well as the block diagram. So for your understanding, I will be explaining about this timer one, so which is a little bit small, so you can understand easily. So this coming to this raw.io website. So this raw.io website consists of some basic components like rectangle, circle, triangle, cylinder, and the lines and the arrow marks which you need, and it consists of some polygon, mm, semicircles, parallel lines, the polygon, partial triangle, semicircle, cone, octagon, and the arrow marks which you have the bended arrow, mm, and the components required for the flowcharts, database, delay time, card, data. These symbols can be used and it can be placed here, and you can use the arrow marks to combine them. So it is very user friendly, so you can draw the flowcharts and whatever required for you. So I'll be explaining about the timer one. So this is the timer one, block diagram. So coming to this block diagram, so you can adjust these blocks as of your wish. So you can adjust these lines and you can connect from one to another block. So even you can export these files. You can save these files as PNG, in a PDF format. You can export these files as HTML, XML, URL. You can share this to everyone, and they can also edit these files using these links. So coming to the next question. So next question is about the instruction set of the microcontroller. This instruction set can be available in the Philips website. So you can download this instruction set by typing this microcontroller name. This complete instruction set will be available under Philips website under NXP section. So I will be explaining about this program control instructions. So these contains of some basic program control instructions which is similar to every microcontroller. So there will be some instructions which is different from compared to other microcontrollers. So the first one is about the BTFFC, so bitwise. So it checks whether the bit is 0 or not. If the bit is 0, it skips the element. So BT as is f is equals to 1, it checks the whether the bit is 1 or not, decrement the f is z. So if z equals to 1, so it decrements the f by 1 and increments f is z. If z equals 0, it increments the f by 1, go to k, go to address, call k, call subroutine, and return from subroutine, return LW, return with constant in W, return FI, return from the input, no operation, clear WT, clear watch stop timer, sleep, go to sleep mode. And the third question is about explain microprocessing element. Microprocessing element, these architecture and this flowchart will be available from the NXP website. And coming to the basic components of the it consists of microcontroller. As of every microcontroller consists of CPU, memory organization, RAM, read-only memory, architecture of microcontroller. So I'll be explaining about the CPU, the main task of the CPU. So it performs the task and it gives the instructions to the input ports and output ports. So ALU, arithmetic logic unit. It controls the internal and the external peripherals, and control unit is used which are connected to the CPU, and accelerates is used for storing the results on the future processes. And coming to the memory organization, so memory organization is the module in the micro architecture consists of RAM. So it is the part of the RAM And coming to the RAM, so random access memory. So RAM is an unstable memory and which is used to store the temporary data. So, so the data will be erased whenever we switch off the system, or it resets whenever we switch on the system. So ROM, read-only memory, which is used to store the permanent memory. So the memory will be stored even when the microcontroller is turned off. So it is permanently stored until you deleted it. So architecture of the microcontroller. Computer architecture is a huge topic in itself. We just develop a general picture of how AVR microcontroller works. So it has a Harvard architecture. It means that program and data are stored in the separate memory spaces which are accessible simultaneously. So therefore, while only one instruction is being executed, the next one can be fetched. So this is the partly how one execution per clock cycle can be achieved. So coming to the fourth question, correlate the microcontroller element with the architecture. So this IAS mechanism mission was binary report, and this information can be available from the Philips website. So it weighs about 1,000 pounds, 450 kgs, and the synchronized mission cycles and microcontroller speeds. It explains about that. And coming to the fifth question, elaborate register organization of the microcontroller, and these instruction sets also will be available from the Philips website. You can go through it, and I will be explaining about this. So how to calculate the algorithm. So addition algorithm, subtraction, multiplication algorithm. So using this NXP LPC 1114. So this is the flowchart of this algorithm. This flowchart can be drawn easily using this previously I have said, right, draw.io. So using that draw.io you can easily draw this flowchart and you can perform this multiplication algorithm. So yeah, I'll explain this flowchart explains mainly about multiplication algorithm. Initially this multiplicand is stored in the B register and multiplier is stored in the Q register. So the signs of the register B and Q are compared using XOR functionally, and output is stored in the A. So now at least significant bit of the multiplier is checked, and if it is 1 and added content of register A with the multiplicand, and the result is assigned in the A register with carry bit in the flip-flop. So the content of E and Q is shifted to the right by one position. So if Q of n equals to 0, only shift right operation and content if E and AQ is performed in the similar fashion. So content of the sequence counter, then it is decremented by 1. So then it checks for the content of the sequence counter. If it is 1, and it sends the process, or it returns back to the and repeats the process again and again. So here is an example of the multiplicand which I have taken. So the final result of the A and Q when it is multiplied is 0 110 110 101. So it gives the output in the binary form. So coming to the eighth question. So memory management of NXP is very important. So accessing memory, the protection of the memory and access of memory is very important in the microcontroller. So the protection, coming to the protection, so there is always a danger when we have multiple programs compile at the same time. You may write to the address space of the another program. So every process must be protected against unwanted interface when the other process try to write in a process, so whether accidentally or incidentally. So between correlation and protection requirement of trade-offs occurs in the satisfaction of relocation requirement increases the difficulty of the satisfaction of the protection. So coming to the sharing, so the protection mechanism must have to allow the several processes to access the same portion of the main memory, allowing each process access to the same copy of the program rather than have their own separate copy of the advantage. For example, a multiprocessor may use the same system file, and it is natural to load one copy of the file in main memory, and it is let it share to the those processors. It is the task of the memory management to allow controlled access to the shared access of the memory without compromising the protection. So addressing modes. So coming to the addressing modes, so it contains of four addressing modes: direct addressing modes, indirect addressing modes, immediate addressing modes, and register addressing modes. So these addressing modes, and it has specific operations. So move a comma 4 instruction sets, move R4. So there will be locations also. So you can share the locations in the program memory. It can be stored in the program memory, and you can access them on data memory. And ninth question is about the pipeline and the parallel processing capabilities and hazard management techniques. So pipeline architecture is mainly pipeline architecture can be achieved with the hardware, compiler, and software techniques to exploit the concept of pipelining in the computer architecture. So many processor units are interconnected and are functionally concurrently in pipeline processor architecture. There are separated processing units which is provided for the integers and the floating point instructions. So whereas in sequential architecture, a single function unit is provided. So coming to the hazard management and control, so PPE, so protect the worker with the personal protected equipment. So administrative control change the way the people work. Engineering control isolate people from the hazard. So substitution replace the hazard. Elimination physically remove the hazard. So the 10th question is about the find whether the processor level parallelism is available in the element selected, illustrate cache, conference on the protocol used for handling memory, HIT and misses. So multiple processing elements. So the multiprocessor operates in parallel and independently. Multiple caches may process different copies of the same memory block. This creates cache coherence problem. Cache coherence schemes helps to avoid these problems by maintaining a uniform state of each cached block of the diagram. This is the block diagram. So this is before update, write through, and the write back. So in general, there are three sources of constituency problems. So sharing of writable data, process migration, and IO access activity. So thank you.